I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the optical detectors, pin and avalanche photodiodes and its characteristics. So now, the optical detectors or photodetectors find in applications of many areas like medical, automotive, safety and analytical equipments, cameras, communications, astronomy and industry. And there are different types of photodetectors are available. They are photodiode, photodiode array, light dependent resistor, avalanche photodiode, photomultiplier tube, micro channel plate, image intensifier, position sensitive detector, CCD, etc. So now we are going to see the two important photodiodes. One are photodetectors. The one is pin photodiode. So unlike PN junction diode, it consists of P and N region. This pin photodiode consists of intrinsic region in between the P and N junction. So what happens is, by the inclusion of this intrinsic region, it increases the distance between the P and N conductive layers, so that capacitance will be decreased and the speed is increased. So the volume of the photosensitive region also increases, which enhance the conversion efficiency, that is light conversion efficiency. So the bandwidth can extend to tens of gigahertz. So pin photodiodes are preferred for high sensitivity, high speed and at moderate cost. And pin photodiode, as we see, a typical pin photodiode consists of highly doped transparent P contact layer on the top and undoped absorbing intrinsic layer in the middle, and an N-type highly doped contact layer at the bottom. So this diode is evolved mainly from one basic requirement, that is, light should be absorbed in the depletion region of the diode to ensure that the electrons and holes are separated in the electric field and contribute to the photocurrent, while the transmit time must be minimal. So this implies that the depletion region is larger than the absorption length must exist in the detector. So this is easily assured by making the absorbing layer undoped. So only a very small voltage is required to deplete the undoped region. So not only that, there is an added advantage is that the recombination or generation time constant is longest for undoped material, which provides a minimal thermal generation current. And next is the avalanche photodiode as shown in the diagram. So photodiode with internal gain is APD, and it internally multiply the primary signal photocurrent before it enters the input circuitry of the amplifier, and this also increases the receiver sensitivity. The photocurrent is multiplied before encountering the thermal noise associated with the receiver circuit. For carrier multiplication, this photogenerated carriers must traverse a region where a very high electric field is present. And there is a high field region where the photogenerated electron or hole can gain enough energy so that it ionizes bands in the valence band upon colliding with them. So this is called as impact ionization, and the newly created carriers are also accelerated by the high electric field gaining through energy to cause further impact ionization. This phenomenon is called the avalanche effect. So create an extremely high electric field region is required, and also it requires high reverse bias voltages from 100 to 400 volts in order that the new carriers created by impact ionization. Carrier multiplication factors as great as 10 power 4 may be obtained. And in APD, it is depleted by employing high electric fields. All the carriers drift at saturation limited velocities, and the response time for these devices are limited by the three factors known as transit time of the carriers, time taken by the carriers to perform the avalanche multiplication process, the RC time constant incurred by the junction capacitance of the diode and its load. And the rise time between the 150 to 200 picoseconds and fall time of 1 nanoseconds or more are quite common, and this limits the overall response of the device. And multiplication factor m is given by the measure of internal gain provided by the APD and is defined as m is equal to Im by Ip. Im is the average value of the total multiplied output current. Ip is the primary photocurrent. So, the avalanche mechanism is a statistical process, and not very carrier pair generated in the APD experiences the same multiplication. Thus, the measured value of the multiplication factor m is expressed as an average quantity which is greater than 10 power 4. So, some of the advantages and drawbacks of APD. APD provides increased sensitivity and wider dynamic range so that the gain variation with response time and reverse bias. And even though it has more advantages, there are some disadvantages are fabrication difficulties because of this complex structure. It increases the cost also. The random nature of the gain mechanism, which gives an additional noise contribution, and often high bias voltage is required, and the variation of the gain with the temperature is also necessary, there. So temperature compensation is necessary to stabilize the operation of this device. So this tabulation gives the APD versus spin photodiode for various materials. And assessment, the depletion region must be dashed to allow a larger fraction of the incident light to be observed in the device. As answer, thick. Because pin photodiode, the intrinsic conditions are created in the depletion region. The depletion region must be thick in order to achieve maximum carrier pair generation, and also its width must be limited to enhance the speed of the operation of pin photodiode. And electron hole pairs are generated in, we know it is in the depletion region. Thank you.